Machine Learning Deformer. It's an exciting new deformer that is available in Unreal, and it should be noted it's also an available deformer now in Maya. What we're seeing here is part of the demo from Unreal showing how the ML Deformer can be used to achieve high quality deformations in the Unreal Engine. Let's dive right into it. Let's do an example where we will take our character Blaze from Advanced Skeleton here and export him over to Unreal. Now, our demo character here does not have very complex muscle deformations, but it does have a delta mush deformer, which is a great little deformer that is easy to apply, and it gives much improved results. And you can always select the deformer and dial the envelope up and down to see before and after. So you can see once you apply the delta mush, it looks much better. So this is a case we do not have the option in Unreal to apply a delta mush deformer. It does not exist, but we can use this new machine learning deformer to teach Unreal how to essentially get the same result. Let's start out here by exporting into an FBX file, which we could do just by hitting FBX export, but instead what we'll do it manually, because we are going to do a few things later on. We're going to export only the geometry and then only the animation separate. So it's better to understand how this button operates, and to see what it does, click on the help button and it'll tell you all that it really does. It selects these two nodes, the deformation system, which contains the deformation joints, and the geometry, and then it basically performs this file, export, selection, and chooses FBX. So let's do that. Let's choose this, the deformation system, the geometry, and go File, Export Selection, and we'll save it as Blaze FBX. And I'm going to turn off Bake Animation and Animation to make sure there's no animation in this file. Export Selection. Okay, that's been exported as an FBX. Let's jump over to Unreal, and what we're going to do, we're going to launch our Unreal 5.4. Although 5.5 is available at the time of this making, there is issues by running the ML Deformer in 5.5. I'm sure that will get sorted. But for now, let's just run 5.4. Let's just make a new third-person project. All right. And I'll make a new folder here. We'll call it the demo. Then I will just drag and drop our FBX file in. All right, now it gets more interesting. There is a plugin from Unreal that gives you this Unreal ML Deformer menu that has a random post generator, and it has some buttons to export the FBX and the geometry cache. If you wanted to download and get these buttons, just go to the Unreal Asset Store and then you search the ML Deformer for Maya and follow the instructions. But in our video here, we will not be using these tools. Like you can see here, it says the recommended range is 5 to 25,000. That is a lot of frames, and it takes a long time to do the geometry cache export and import. So we are in this video, I'm showing you a slightly different workaround with much less frames. It seems to be working fine, so this is what we're going to show and what I'll be recommending for now. Let's do it. Let's fire up in this section here called Tools. This new button here called Machine Learning Tools. It says Set All to FK. Yep. Applying training animation. We get about 300 to 256 frames, much less than the 5 to 25,000 recommended by in the Unreal documentation. So this is gonna run much faster, and you can see what it does. It instead of applying random animation across all the joints, it is applying the animation in the joints and the ranges that are typical. Now, this training animation, we are now going to need to export into versions, if you like. One is we're going to export this animation so it can be applied in Unreal to the rig that we imported. The other thing is we're going to export the geometry cache. So this is the final solution for how the deformation is going to end up being. Let's start with the simplest one, the animation. So now we're going to export animation only, and it's going to be applied to the one skeleton mesh that's already Unreal. So what we're going to do this time, we select only this node, deformation system. We go to export selection. We'll call this training animation. And we'll make sure now to turn on animation and bake animation. Now let's jump over to Unreal. Drag and drop training animation in. Now what you'll see, because we're dragging it straight into the same folder that has the skeleton mesh, it's gonna automatically complete this and say it will apply this animation to the existing place, skeleton mesh. So import all. So there we go. We just got that one extra node, the animation. Double click to test it. We see that that indeed is what we wanted. Back to Maya again. This time we're going to export the geometry cache for the final deformation, how it appears here in Maya. And to do that, we are going to use the cache menu in Maya, Olympic cache, export selection to Olympic. And I'll call that training animation cache. Now we're going to input this cache. We'll drag and drop it in. Here comes an important step. We're going to change static mesh to be geometry cache, and important here is to click on the options that says flatten tracks. That's got to be off, and under advanced, this one that says store imported vertex number got to be on. Then we'll hit import. All right, we're now starting to have most of the ingredients that we need to cook up this machine learning deformer, but we will actually do one more piece of animation, and that's the one we're going to use to be testing our result. I mean, we could test using this animation, but it is not that interesting to look at, and so we want a more generic motion animation. And what we can do, we'll say remove training animation, and then we'll go to this thing called animation tester. Under the motion test, there is a option here that says range of motion. And this is just a generic range of motion of the character doing some generic stretching. So we'll be using this to test our final result over in Unreal. So select just the node called deformation system, export selection. We'll call this RON, range of motion. All right, once that's exported, again, jump over to Unreal, drag and drop that FBX in to the folder where we already have a skeleton mesh. And there we go. We have the ROM animation clip here. All right, time has come to create the ML Deformer. And now that should appear here. Like you right click and say you want to create the deformer. It does not appear on the list by default, and that's because the plugin needs to be loaded. So what we can do, we just go to plugins. In the search field, type ML, and there's actually two plugins that we're gonna need. First of all is the main ML Deformer. That's the one here called ML Deformer Framework. All right, that's on. Now there are different what's called models, which will do different deformers, but basically the one that is recommended and the one we're going to work with is neural morph model. And as it says here, we have to do a restart to make these plugins work. So let's do that. Save selected. And once that's restarted, we now are able to right click, say animation, deformers, ML Deformer. There's our ML Deformer node. We'll double click to open it up. Let's start filling this in. Our base mesh is going to be our base guy. There he is. Then he's gonna need some inputs. He's gonna need a animation sequence and a geometry cache. So the animation sequence is our training animation, and geometry cache is the training animation cache. Already at this point we get that timeline available, so we can start scrubbing the timeline and start seeing some interesting things here. Let's just go to frame 3 for a start. What we can see that the guy with the textures is the one we imported, so that's using the basic skin cluster, and the gray guy over there is the geometry cache, so that's the one that has the advanced deformations from Maya. Basically it has delta mush deformer applied. So what we can see here is that the deformation on the knee bending is not very nice. You get that typical issues like the cavity and the volume loss on the one that's using just the skin cluster, and it's looking much better the one that is the geometry cache from Maya. And we start seeing these green lines that is essentially indicating the difference between the two, and that's what the machine learning deformer is going to be looking at. It's going to look at, there's the difference between the two, there's the joint that's being bent. It will try to learn that relationship and it will become the deformer. So it's a good idea just to scrub through the timeline here, make sure it all makes sense, that the green area is highlighted in the right places. Next, it says the training process needs inputs. So basically it needs to know what bones to work with, and there's a button here that says grab all animated bones. It will detect which bones have animation and use them to learn from. Now, I recommend here to remove the ones that are not strictly needed, and that's going to be all the one called part joints. What we can do, you can just type in the search filter, we can type part of these joints. So just select all the ones that are the result of the part search and delete these. And then we can remove the search filter. And you see that we also have these slider joints. So we can also type slider, select all from the result and delete. Alright, so now we're left with just the basic raw skeleton, which is the hip, the knee, the ankle, the wrist, the ones that have animation here without any of the helper joints or any of the twist joints. So shorter bones list, it's going to make the machine learner deformer have improved results and faster to compute. Next step here. This is important because we are essentially cheating the system a bit. We're not using the recommended 5 to 25,000 frames of random post training. We are just using 256 key poses. Now, we're going to need more than 6 poses per bone. What I recommend is that we take the number of morphs 24 instead of 6. Likewise, we're going to open the advanced section and match that the number of neurons per layer is going to be the same. 24 there as well. Now, time to hit the big button. Over here it says train the model. Alright, training completed successfully in 4 minutes and 23 seconds. Now that this is completed, there is a neat function inside the ML Deformer interface here, which is testing. We can switch from training to testing. Then we're just going to give it a animation sequence. Now in here, you could use the training animation if you wanted. Now that's going to be just that same animation that's used for training, not that interesting, but we did also export the range of motion, which is a more interesting animation with this character stretching, where will be more interesting to see the difference in the results. All right, but first thing we want to address here is that this is looking a bit funky. See all these gray areas in here? That's actually a issue that we can fix. We close the ML Deformer, go into project settings, and instead of navigating to find the setting, we can just hit the search box and just type skin. It's called support compute skin cache. Turn the checkbox on, and again we're going to have to do a restart, so let's do that. And once we are relaunched, we'll again open the ML Deformer node. And we can see that that gray shading issue has been resolved. Okay, one thing here is the pants. The pants are not attached. Some interesting things to say about that, because it's, well, essentially wrap deform in Maya. Wrap deformer doesn't work in Unreal, but we can also use the ML Deformer to simulate the wrap deformer. So for now, ignore the fact that the pants is not attached to the body. But let's look at the settings that we have to work with here in the testing section of the ML Deformer. This is where essentially we're going to see the difference with and without the ML Deformer. So without, it's the linear skin labeled here on our left, and the ML Deformer. Now to more clearly see the difference between the two, you can turn on show heat map. So that's an interesting way to see it. And if we hit play, you can see the animation playing and then the heat map showing the areas where it is applying deformation. So that's looking quite correct. We can test with and without. And let's go to this frame. With the knee slightly bent, you can see here that the default skinning only definitely has issues. Whereas the one over here looks better. If you turn off the heat map, you can also control the weight attribute, which is kind of equivalent to go to Maya and dialing in and out the envelope attribute of the delta mush. So here we have the envelope or the weight attribute of the ML Deformer. So we can quickly see with and without that this is without and without. So definitely improvement on the bending knee and all over on the body. The much better body deformations. So this poor guy's revealing too much without these pants. So let's get these pants included in the ML Deformer. And that is a interesting thing that we can actually now jump into Maya. We can see that it's a wrap deformer applied on the pants. Now the wrap deformer on the pants is a good little trick because it can help you avoid the problems with that you would, if you were skinned, it would very easily intersect with the main mesh of the skin. That's avoided by applying the wrap deformer. So let's get this pants included in the ML Deformer. The way we're going to do that, we will include it in the geometry cache. So let's select both the pants and the skin. This time, cache, Alembic cache, export selection to Alembic. I'm just going to save it as a separate cache, so it will be number 2. All right, now it gets a little bit tricky because now we essentially need to export a new skeleton mesh FBX file where this wrap deformer has been replaced with a standard skin cluster. So at this point, if you're having a complex setup, you're probably going to want to split into 2 separate Maya files. So you have your one Maya file, which is the one you're going to export that will become the standard skeletal mesh, and another one which will become the geometry cache, essentially the target or the high deformation. But for simplicity, I'm going to keep it all in one file here. I'll go over here. I'll just delete the wrap deformer for now. Then I'll bind it, which with that selected, I'll just go deform option 1, select deform zone, smooth bind. That will bind it, and just to give it some decent initial skinning, I'll select the skin and the pants and go to skin, copy skin weights. Now to give it a quick test, I'll try moving the body. You can see that the pants are following. However, if we rotate, you see we straight away start getting these problems with the pants intersecting with the skin because, well, skin clusters. That's part of the catch with skin clusters. So now we're going to train the ML Deformer to see the difference between this skin cluster version of the pants and the wrap deform version and apply it as the machine learning deformer. Let's export this now. It's going to become our new skeletal mesh. So essentially select the form system plus geometry, export selection. Again, we're not interested in the animation at this point. So we'll turn off bake animation and animation. I'll call this Blaze 2. And in Unreal, now because it will associate animation with skeletal mesh in this that are all in the same folders, Let's, for now, to make this more simple, make a new folder, calling this number 2, just to make sure that we can import Blaze 2 into the folder called 2. Go to the default option, so that's going to get us a skeletal mesh. We can then jump back into the demo folder. We'll reopen the ML Deformer. And here we're going to make sure this is now the skeletal mesh is our Blaze 2, which is the one with the skin cluster on the pants. The animation sequence, that's still going to be our training animation. The geometry cache is going to be geometry cache number 2, because that's the one that's including the pants. Then it says, yes, that's going to need retraining, and yep, that makes sense. Let's hit train model. And training complete. Let's jump over to testing. And this time we'll see if we scrub through the animation, the pants are indeed attached. And we can do some comparison even if we say go to this frame. You see that one on the left here, which is the normal linear skinned pants, will have the typical issue of skin penetrating through the pants, whereas the machine learning deformer has here trained itself to behave like the wrap deformed pants and avoids the skin penetration. Okay, so far so good. We got the machine learning deformer working here inside the ML Deformer UI. Now we're gonna need to do some extra steps to make this work in the main Unreal editor. We do need to make a new animation blueprint. So make blueprint class, make actor, open it up. And this is where it's going to come together, the skeleton mesh and the ML Deformer. So what we can do, we can drag and drop the skeletal mesh in. Now, if you just drag it in, you'll get that little default scene root object in the middle. We don't need that, so you can just drag and drop that on top of that to remove that. All right, now we got a blueprint that has the skeletal mesh, and we'll go ahead and add a ML Deformer. And in the details pane here, where it says which ML Deformer to use, we will use our new ML Deformer. Now, to quickly test it in here, what we can do is say our skeletal mesh, instead of using animation blueprint, it can use a animation asset. Grab the ROM. Actually, let's stop it from playing and just pick a frame. It's more easy to do some testing. And swap the weight between 0. There's our rough result we get from the standard skin cluster. Set the weight to 1. Here's the much improved result that we get with the ML Deformer applied. And if we wanted the blueprint in our scene, we could just drag and drop this guy in. You just hit play and start the game. Now, we did use the third-person character template, so we got this character in here that can run around. But yep, we can run over and have a look at our Blaze character that's there. He's animating, he's doing his range of motion, and he's got the improved deformation because he's using the machine learning deformer. Okay, now there's one more thing we're going to cover here, and that is what if we want this machine learning deformer to work with control rig? Or in other words, what if we wanted to animate in Unreal and have the effect of the ML Deformer? Let's give this guy a control rig, which we can do fairly easily because advanced we have a function in the export section that says export the rig as a Unreal control rig. We use the Unreal 5.4 template, and we'll call this file Blaze as well. Jump back to Unreal on the skeletal mesh. We'll right click and say create a control rig. Now, to make the control rig build much quicker, first thing we want to do is open the control rig and turn off the auto compile function. That means the script's going to run a lot quicker. Now we'll make sure the control rig is selected, go to Tools, Execute Python script, and choose the Blaze Python script we just exported. And then we can open it to make sure it looks correct. there's our guy with the rig. And since it's not auto-compiling, we'll just hit compile. What we're going to do is use that same blueprint. So open the blueprint. We select our Blaze to skeletal mesh. Now we have previously set this to use a specific animation. Let's just change it back to the use animation blueprint. And there's a section here that's asking which control rig to use. So we can just type rig and it says animation rig. We'll turn it on and we'll use Blaze control rig that we just created. And that should do the job. We can now close this. Now to get the control rig showing in the scene here, we just need a new level sequence. So we'll just hit create a new cinematic level sequence. Now to place our control rig where we want it in the level sequence, what I'll do, I'll just drag and drop the blueprint to the right location, open the level sequence, and then we'll drag and drop that blueprint into the level sequence. That will give us the control rig at the given position. And we can now grab and rotate the controllers. And it is essentially, we are controlling the rig with the control rig, and it has the machine learning deformer applied. If you wanted to confirm, you can select it, go into the details, pick the ML Deformer and set the weight. Toggle it between 0 and 1 and you'll see the difference. Now, disclaimer, you are not seeing the full proper deformation here in this case because we have simplified this setup to make this video somewhat less complicated. There is still another level of deformation going on here that we did not include. It's fully possible to include, but we have not because this video would run much longer. But basically, if we take a closer look in Blaze, in Maya, apply some pose, we have a set of controllers, actually a lot of controllers underneath here. We can turn on partial, as you see, we got a whole bunch of controllers, and these are automatically driven to move around to improve the deformation as these controllers are adjusted. And you can get a glimpse of this if you go to the pose section under driving system advanced, create a blendable preview node, so you can here you can dial in and out to see the effect of this essentially automatically driven custom controllers. So we could get all this working and replaced by the machine learning deformer, but that would require us to essentially make a version of our Blaze rig that does not have this setup and then train it up against the geometry cache that has this setup. Maybe we'll do that in another video. It gets complicated and there's even more possibilities to take it even further. We could replace the entire twist system and twist joints with single joints at these locations, and instead of deriving the twist throughout the bones, it can all be replaced with machine learning deformer. It gets really complicated. It's gonna have to be in another video. For now, this was hopefully an introduction to what the machine learning deformer is capable of doing in Unreal, and open up a whole new world to us where we can do complex deformation in Maya and get Unreal basically to behave pretty much the same by using this machine learning deformer. And that's it for this time. I hope you have enjoyed this video, and I'll see you next time.